I think there's room for a lot of different kinds of data scientists.
Exactly, and maybe that's one of the key points, that we have grown from a quite one broad term, and now more maturity means it's sort of branching out more clearly. We have talked about the analytics versus machine learning engineering.
Right.
It is different.
And I know you have some ideas about recruitment and the good way and bad ways to do that.
Right.
Perhaps that would be a fun topic to have at some point soon.
Sure.
Yeah.
But before we do that, can you just quickly introduce yourself? Who is Robert Luciani?
Right. My name is Robert, and I have a bit of a multinational background. I was born in the US. I lived in Italy for a number of years, the United States for a number of years, and now I'm mostly Swedish. I've been here since 2000, so that's 20 years now. So more Swedish than anything else, I suppose. And I have a number of interests in addition to computers. I really like computers because they feel like magic a little bit, I guess. And I like Olympic weightlifting.
Really?
I like first-person shooters, like Quake. And I like music
Quake 3,
a lot.
Quake 2, which one?
Quake 3, yeah, the competitive arena ones. I like Quake 1, all of them from the beginning, so it's good.
Yeah.
And then music, of course.
Yeah, and music is a big thing. I've played in a number of bands, signed at labels, and been doing that for a long time. And I guess the genres of music I like are the ones that are most pretentious, so like jazz fusion and that kind of thing. But I like the energy of heavy metal, so I try to blend them.
See, it's because I know you more as a heavy metal guy.
Yeah.
But you have more of a jazz fusion.
Yeah, I think
going
so.
on now.
I think the metal is the part that you hear the most because it's the loudest part. But there's a lot of theory and music theory underneath there. Yeah.
Cool. And so you're in a band right now? Are you
No,
doing
right now
something?
I'm just doing solo project. I've been writing this album for many years now. It's just a passion project of mine.
Yeah. And how do you sort of work on that? Alone on different instruments, or you get friends in doing different pieces?
I mean, it's super cool because it was actually a Swedish band called Meshuggah that sort of kicked it off by releasing a drum sample library that let people write drum parts, which before used to be cost prohibitive, basically. Now, anybody that has a small laptop, any gaming laptop, can get really, really good music quality at home, basically. So it's really lowered the threshold for how much it costs to get good quality. And since 2005, everybody basically is able to write everything at home and write all their own stuff. So that's a little bit what, I was fortunate to be part of that wave from the early 2000s.
And does this wave have a name? What's the sort of, is this a thing?
Yeah, that particular brand of metal is typically referred to as gent.
Gent.
Yeah, because it sounds like gent. Yeah.
At some point in the future, I will introduce you to dance band, Swedish dance band music as well.
Right,
and,
yeah.
Convert you into that, perhaps.
Yeah. That would be a good argument. Pros and cons of gent versus Swedish dance band.
That would be certainly very fun. I remember at Spotify days, I think I am probably paraphrasing a lot or saying something wrong, but they said, or I think Donnelly X said at one point, so Spotify is a tech company at core, but with music in the heart.
Right.
Is that a good description of you would say?
Yeah, I think I'm often humbled by the depth of all these fields, and I think being an artist is saying very much and very little at the same time. So I like being a musician first and foremost, more than being an expert at any one thing.
We spoke a bit about art before, and what the definition of art. Do you have a good definition of what do you think art is?
Yeah,
okay, I'd love to hear it.
A philosophical definition, and that art is what the art community agrees is art. So basically, it's a gang of people that get together and say, yeah, we all like this stuff. And what I really like about it is that there's no threshold for who's allowed to be an artist or not. You can be a painter and make really paintings that don't look like anything in specific, but it's okay for you to still be an artist. Just not a very popular one, or maybe not a very accurate one, but you're still an artist.
But if you were to just say one day you focus a lot on working with art, and another day you work a lot with some data science AI project.
Yeah.
Is there something that is fundamentally different about what the purpose is, how you work, or instead of this kind of circular reference type of definition, which I have some problem with.
Well, it is. It's a very self-serving type of narcissistic definition. The everybody that likes it can join the club, and now we're artists.
Yes, exactly.
But it used to be that art was, if you're an artisan, right? If you're making a sword, you're a smith, and your art was banging that sword in such a way that it was, spectacular when it was produced. And really what you'd done is laid your soul bare into the sword. This was the expression of your skill. It was your art. And then came art that served its own purpose, like dance and that kind of other thing. But it's all art. And I guess one thing that links us humans to art is that a lot of art is irrational. It's part of our brains that is very distinctly human. And there are some really neat things that link us to music and other kinds of art. So in particular with music, I don't know if it's because speech is so important to humans, but I think there's a short circuit from our ears to our brain where we hear symmetries especially well. Because birds are very good at hearing and understanding frequencies and everything, but they don't necessarily get triggered by and even small children understand that in a special way. So we probably have a little bit of a bug where our ears are connected a little bit too strongly to parts of our brain that get stimulated by symmetry and sound, either in harmony or beats and that kind of thing.
So is that a bug or a feature? I mean, would you say that you have some kind of help of being an artist in the way you are, in the work you otherwise do for more professional purposes, so to speak?
I think mostly just makes me a little bit too excited about things that I find fascinating. And just to go a little bit deeper in that symmetry thing, when you hear a beat or some harmonies or some melodies that just really speak to you, that's basically symmetry in the music piece, in either in time or in frequency. We don't get that excited about seeing rocks that are symmetric or other things. We do about faces and that some kind of thing, but really it's about what kind of sort of patterns that we get excited about discovering. So there's something very special about sound compared to all the other stimulus that we get. Like if we rub our fingers across a surface that has a regular pattern, we don't get as excited about that as we do about the bass kick or something like that.
And how did you got into computers? So what's your computer story? Are you a hacker at some point in your life, or how did that start? The whole computer fascination.
I guess it started with video games, that you could play video games, and I felt they were so mysterious. I felt very unlucky when I was growing up that I had missed the internet revolution and the 80s, and when the big vac machines and everything. It felt like after that, it's all been done. Now it's just sort of incremental improvements. And so when I was at university, I was like, I guess born in the wrong time. And now I know that that's not the case. And we are right in the middle of the machine learning sort of takeoff. So that's good. And there'll probably be similar types of
So
things.
you started, when did you get started to code? When was the first time you coded something?
On my TI-82, I think it was, I made role-playing games with Visual Basic.
Cool.
Yeah.
So how old are you then?
I don't know. I guess I was pretty old. I was like 13 or 14.
13, 14.
Yeah.
Cool.
But I felt computers were mysterious. Like you saw a prompt and there was something magic going on behind it. And when you send it commands, it would go into the void and then come back. And I was like, how is it doing that? How is it thinking, basically? And now we've said, that's easy. It's the advanced AI stuff that's advanced. We've sort of pushed the goalpost forward for what intelligence is. But to me back then, that was so mysterious and magic. Yeah. And that's what I wanted. And I felt that operating system hackers, those were basically the wizards of programming. So when I was younger, I wanted to become an operating system designer.
Oh.
So I started learning a lot about, that's why I studied computer science. I wanted to learn about parallel processing and all the challenges that OS designers had. And I learned a lot from that because they have to solve the general problem. They're not allowed to solve a specific problem. Like if they're writing a threading library, the threads have to perform well in all circumstances, for a video game, for a database, and for everything else. And that's a lot harder than like when Hadoop came out and he was like, you can map reduce. Look, if you have a problem that's embarrassingly parallel, you just ask many people to solve each part of the problem. I'm like, but that's not a hard problem. The hard problem is if you have one resource that everybody has to share and fight over. So I didn't even get what Hadoop was good for, and obviously it's good for lots of stuff, but I was so much into the operating system thing that was just the only thing I stared at.
It's amazing how Hadoop can make something so embarrassingly, parallelly simple to do, extremely complicated.
Yeah, it's a lot of code for very little. Yeah, sure.
And so what's your your journey into the industry, so to speak, or from studying and what's that journey all about?
I think the biggest lie we're told in university is that you need to do a career. You need to make a career. And the career is to get a good title and then get a better title. That's what the career is. And you can cheat your way forward, because if your title has the word manager in it or something, then it's better. And what they should have said is you need to focus on improving yourself. Get really good at something and invest in yourself. And if you're really good and you provide a lot of value to people, you'll do very well for yourself. And I'm still learning it now. Even now I'm thinking, oh man, I should have just focused on doing what's right, what's good, what's interesting, instead of trying to be clever about that kind of stuff. So I went to university precisely because that's what you're supposed to do. And I was there for 5 years, and I'm so bad at school, and I didn't pass the tests or anything. I went to lots of courses and did a lot of neat open source stuff. But on the other hand, I wouldn't have gotten my first job if I hadn't been at university. So I guess that was a good thing.
Speaking about careers, I think you have a very interesting career. And you started off like a super big company, and then moving into having your own consultancy and your company and doing that. Can you start off? How did you get started at Microsoft?
Right. Microsoft had a really nice trainee program.
Yeah.
Those programs are really good at many of these big companies, because they're made to teach you a lot of the things that are required at big companies. Processes. Running that or getting that many people to work in the same direction is super challenging, and it's not until you work at a huge company like that you're privy to all those things. And when I went down to smaller companies, I missed a lot of the things that were from Microsoft. But the reason, so Microsoft was basically the dream job. Everybody at university wanted to work at IBM, Google, Microsoft, and all these places. And I'm always going to have a soft spot for Microsoft because what it did for me and what I learned. And I still think Apple is a bit prissy. I don't want to, I don't want to have a MacBook and that kind of thing.
Perfect.
But,
look at this. One of the best thing I love about Robert. Okay, good.
But and it's actually I was the BSD Unix guy at university. So a lot of people say, "Oh, you're such a traitor starting at Microsoft." And I'm like, this is what you're supposed to do. And back then, it was right when Windows Vista was at the end of its life cycles. It was the worst time to start at Microsoft. But I learned that.
Which part was it you worked at?
Well, I was at Microsoft Sweden, which is a sales organization. So I was technical pre-sales, and I had lots of great customers, from the central bank to IKEA to everything. And it was a real privilege to get to work with all of them. But what I learned quite quickly was that, all these big companies have company values, and we're going to change the world. But it's not a team of 5 people. It's a machine. And if you're not running in the same direction, you're going to get run over. And it's nothing specific about Microsoft. It's just any big company like that. If you're not headed in the same direction as them for a moment, you'll just get run over. And I resented that a lot. I took it very personally because I thought we were all friends and we would just work together and stuff. But it's not. I mean, the company has one direction, and if you're not really headed in that direction right then it doesn't suit them. So I changed, and I kept on going to smaller and smaller companies, and I started my own company after a while, and I don't think I can ever go back. But it's a weird thing because, like I said, I'll always have a soft spot for Microsoft, and I'm extremely grateful for what I learned during that time.
So I think we see a lot of people, taking this journey, and I think there is good reasons to do so. But if you still were to give some advice to someone that is perhaps coming right out of university and thinking, what should the first company be, how would you advise them to proceed? I
would say if you the thing about a startup is you're risking a lot.
Yeah.
If you are older and you have a family that relies on you and that kind of thing, it's not very easy to be living off noodle money for months. So probably when you're out of university is the best time to do it. It's when you have the most energy. It's when you have the fewest commitments. That's the right time to do it. And I think
to do what? To do startups?
Yeah, to create a startup. And it's not as bad as it seems. It's not as hard as it seems.
Do you think a junior right out of university could create a startup and that would work well? Or
that a what?
A junior right out of university could start a startup and that would work well, you think?
I think if you're willing to accept that you need to get a lot of mentorship. Yeah, I think the reason it's working for me is precisely because I knew all the things from Microsoft to be careful
So you
with.
didn't take that journey. I mean, you
No.
started at a big company,
Yeah.
you got the pre-training,
Yeah, for
you
sure.
got introduced to a lot of thinking that,
Yeah.
really experienced people had, right?
Yes. Yeah, I mean, I knew the language that I needed to have with me in business meetings. I knew how to balance our liquidity at the company. I knew all that kind of stuff. So that was a little bit of cheating. But I think if you're humble and you have mentorship, you might be able to make that journey anyway.
Because I sometimes feel, and I certainly was the same when I came out of university, that I thought I knew the world and I was better than everyone, and no one could ever tell me what to do. And then you actually start to learn more, and I started my PhD and everything, and I started to realize I know nothing. But it took quite some time.
I still learn that today.
Yeah, and sometimes is that good or bad when you're doing a startup? Because I think doing the startup, I mean, it boils down to, of course, having something really concrete, contributing value that is good, right? I mean, and of course, if we are cynical, most startups don't work.
But 90% plus or something.
But of course, in the end now, if you look at the lean startup methodology by Eric Rice, I'm not sure if you've. It's like this. One of the key success factors of a startup is basically how fast can you iterate on your minimum viable product, and then benchmark or measure if you're on the right track, and then pivot or persevere and all this kind of stuff.
Yeah.
So I think sometimes it's a little bit like you're also hindered when you have been in the corporate world that you have almost like dogma with you how things should work.
Yeah.
So that whole first principle, reinventing stuff, it could be that you're fresh, having great idea, as long as you're also humble about mentorship, but also about this is a journey, this is a learning curve.
Yeah.
So the first startup, the second startup, the third startup, well, that's your years 5, 6, 7, and 8 in school of life.
Yeah, for sure.
So and then the whole bottom line is the whole thing, I think, with risk and family and having the really being able to put in 200 hours.
Yeah. I think that to what you were saying before about knowing everything when you come out of university, to clarify to people that might be thinking, well, maybe you didn't know everything, but I know everything. And the thing is, it's not that you're wrong when you come out of university. Let's say you have a great idea for a product. It's not that your idea is not great. It's just that there are a lot of unforeseen circumstances. There's motivations behind business decisions that might not be clear from the beginning.
The point is you're extremely naive on why people buy products.
Yes.
Or why people and how you sell.
Yeah,
so you think if it's good it will sell. No.
Exactly.
There are other topics.
Yeah, it's not the best product that wins.
It's not the best product that wins. It's about how you manage risks or concerns. It's about other things.
Yeah.
And this naivety will kill you in the beginning, of course.
It's a large number of unknowns, so to speak.
Yes.
And you don't even know the unknowns
right.
when you're a junior.
Meta
But
unknowns.
Exactly. So
Yeah.
you start to learn, oh shit, there are so many unknowns I don't know about.
So,
and then,
and I think that's the point. If you, it could be a great idea, but be humble, be hardworking, be disciplined, pivot.
Yeah.
If you think you know the shit and you're going to have pride in it's going to be my way or the highway, you can forget it because you probably don't have it right the 3 or 4 first times.
Here's a topic that I don't know if we should go too deep into, but it's is it important to make money?
Yeah.
Yeah, good one.
Good
Right?
one. Yeah.
So why do you start your own company, actually?
Well, I mean, nobody's making money nowadays, right? They're in the red for 10 plus years. And some of the companies that we're looking with now that are viewed as extremely the paragons of success or even innovative, all that kind of stuff, they can be read for long with no green in sight in their budgets, making a profit. I don't know if there is... that's a pretty recent phenomenon, is it not? I don't know if that...
What do you mean that no one is making money? I mean, there are a lot of companies that make money, right?
Sure, I mean, make money, but I mean being net positive over the course of the year. So
you mean startups now? Or
Yeah. Well, some of
even-
these startups are pretty old now. They're like 5-6 years old, and they're still digging into... They're still not making... they're making money, but they're not making a profit at the end of the year.
Yeah.
And that might be part of the plan, but I think that's a new I think that's a new thing, that now it's viewed as very okay to have a really long runway, whereas in the old days a lot of people would say, well, you have to be profitable year one, otherwise it's not a good thing.
But I can relate. I've actually been trying to follow up on these topics and read the unscientific way, Googling and following different people with opinions, and it seems like there has been a shift, especially in the Silicon Valley mentality, that basically you have a business model and you sell and you get into the whole VC selling. Mm-hmm. So basically the whole business model is actually geared towards acquiring capital versus acquiring customers. I've gone down and looked at it and read about a couple of who's sort of reflecting on that. It's like, we are really, maybe this is not so healthy, because the way we are pushing stuff now is making more effort towards the investors than rather trying to do good products and get customers. And I think that's the whole point, that you're going for the investor route very early.
I mean, I don't know if it makes sense, if we can figure out exactly whether that's the right strategy or not, but I think a lot of companies now, when they want to make a startup, right? You're at a university, you want to make a startup, and you're going to either a VC company or an angel investor or something like that, and you're saying, my plan is to build a product, I'm going to go into a cave for a year and then come out and the product's going to be ready and I'm going to be selling. Is that the right approach, or should you try to, from the beginning, go out and sell and have a plan for earning money as soon as possible? And I think that runway that people say we need to be in the cave for 3 years because we're going to build a product that's so complicated it takes us 3 years to develop it, and then the money's going to come in 5 years or something. I'm not sure I have the right answer, but I have to say it feels a lot better at night knowing that money's on the way in. It's going to really hurt your stomach if you're deep in the red and you have people hanging over your shoulders.
But I'm very opinionated on this, that I think this is quite an obvious answer to this, that you kind of want to go the whole lean start philosophy, try your stuff out with a minimum effort to see if you're thinking right. Because to think that you will have the perfect fit of your feature towards a customer base, you're not going to know until you've tried to sell it and someone bought it. So how fast can you get something that gives you concrete buying feedback is probably the most important. Because I would find it extremely scary that someone says, I'm gonna be on my own now for 1 year. Yeah. I'm not going to talk to customers, and then I'm going to have it spot on.
Yeah,
that to me, come on.
Yeah,
that's my opinion.
Yeah. No, but it's also, I've had this question so many times, and I'm also a bit opinionated here, and I'm trying to bite my lip.
Don't.
Not speaking about this, but
tell your opinion on this.
No, but being in the red, as long as you scale, I think that's perfectly fine and even a good thing. Mm-hmm. The problem is really when you don't scale and still in the red. Right?
Sure.
So scaling is more important than profit. Would you agree with that?
I mean, if it's part of your plan to turn it into profit at some point, that's the reason why you would scale.
Exactly.
You can obviously invest in yourself to grow bigger in the hopes of being bigger later and making even more money.
I mean, if you make a small profit, why shouldn't you invest it in scaling more?
Right. Sure.
Right? That would be stupid in my view.
But I guess the question then is, if you make a profit and reinvest it, or if you go out and ask for more money because the money you got ran out.
Yeah. But either or, scaling is number one in that case, right?
Not to challenge you, but to balance it, because I think that...
You can challenge me as well, that's fine.
I think you're right. Essentially, I think you're right to a degree, because I think it has a lot to do with what your fundamental business model is all about. So if I take the traditional, how we defined the new disruptive, how we talked about digitalization, 2016. We talked about the Ubers and the Spotifys to become the platform, right? So here clearly, in the end, the market will be run by 3 or 4, or maybe only one platform. So here for sure, scale beats profit until you have that critical mass that you are the number one. I mean, like GE, Jack Welch and GE talked about either we are number one or number two, or we get out in each market, however we define the market.
But
so I
it
think
is a gambit,
this is
right? As long as you're in the red, you owe someone.
Yeah,
in a sense. And the longer you're there, the longer you're gambling and saying this is going to pay off at some point.
Yeah. And it's also about being innovative, I would say. Yeah. So if you want to simply make money quickly, you just go for the mainstream and do what they want, and then good, you have some short-term money. But if you truly want to disrupt something, you have to start at a scale where you will not make money, and later scale into that.
Yeah.
Otherwise, it will be, I would say, strange, right?
But I think, but let's take another type of business model.
But let's ask Robert as well.
Please, sorry, this was a good one.
I don't think necessarily it's this type of software that we're trying to develop now at Foxrane is one where if we start to grow a little bit, we could definitely reinvest that immediately so that we keep none of the money that we've made. Yeah. And there is no rule book about what the right decision is to make. The only thing I know is what the investors expect, and maybe what kind of salary I want to have in the short term, and what the risks are in trying to grow. Because if I were to take all that money and reinvest it, I would be saying, okay, I'm willing to live like this for one more year and promise the investors that the money's going to come in one more year and it's going to be 3 times as big this time. It's like, like with the stock market almost. And I guess in that sense, there's no easy way to say what's right or wrong. But I do think that scaling principle does apply to more things than just like TikTok and stuff. Yes. We're selling a pretty niche industrial solution, and it applies just as well in Japan as in Sweden. So, if we want to start selling in Japan, that's going to require investments. And so.
And we haven't really mentioned Foxrane in any way as well. So perhaps if you could give a quick introduction to what that is as well.
Sure.
What you do.
So after I said I started my own company, and I was doing consulting work in data science for almost 5 years. And I really liked that a lot. And what I felt was I wanted to build a product that I got to refine, keep, be proud of, and that kind of thing. So that's what Foxrane does now. We build software that, for the time being, is focused very much on solving NP-hard problems.
What is MP?
NP.
Nicholas.
Yeah, right, yeah. It's a type of problem that becomes harder very quickly. It's the type of problem that is very easy to verify if you've solved it correctly, but very hard to actually solve. A little bit like classical music. You can tell it's good, but it's actually hard to write.
This is actually, a favorite topic of mine as well, and I love the article you actually send in advance, talking about the traveling salesman problem for this.
Mm-hmm. So what is that? Let's start with what's the traveling salesman problem?
The traveling salesman problem is one that Sweden is a little bit known for, because it made an animation about 10 years ago where the goal is to visit every city in an area using the shortest path possible. So you start in one city, visit every city, trying to sell stuff, I guess, and then you come back to your hometown. And obviously there is a shortest way to do that. And calculating that shortest path is very difficult. And for every city you add, it becomes exponentially more difficult. So even faster, actually. But yeah, so not in polynomial time. And so, if you're up at 16 cities, which is not very many cities, it becomes essentially impossible to solve. So about 10 years ago, Sweden had some university in Sweden made a nice animation of visiting all the cities in Sweden, and that took a supercomputer to calculate. And nowadays you can do it with less, but in real business, you tend to have constraints. People can't drive 24 hours a day, trucks break down, there's snow, the distance between A and B is not the same as between B and A. You have tons of constraints. And so this problem really becomes difficult to solve. And one thing that I really loved about deep learning when many years ago I started seeing fun examples was people that were using it to approximate solutions to like Navier-Stokes equations and physics stuff and these classic problems that are really hard to calculate correctly. The Navier-Stokes equations are essentially every point is affected by every other point. Now calculate every point. It's not really a solution to anything. It's basically saying that to know how every point is, you need to first calculate every other point. And that's sort of how the traveling salesman problem is solved today in the vehicle routing program. You buy these commercial solvers from IBM and other places, and they basically, I mean, they try to be clever about it, but in rough terms, they're brute forcing it. They're trying every possible combination. And it's just, you know, if you have some problem space that's the size of the universe and you cut it in half, it's still a big-ass space. You can't solve it. So the only thing you can do is tricks, like branch and bound. You say, let's just assume that trucks that cross paths is a bad thing. And then you've sort of reduced the problem space. Except that's a really bad assumption because that's not true. And so you end up embedding all of these assumptions and you end up removing the optimal solution for yourself. So anyway, when I saw those articles, I'm like, man, we should do something with deep learning where it comes up with an almost optimal solution and does it for something that is traditionally super hard to calculate exactly. Mm. Because usually if you come within 1 or 2% of the optimal solution, you're pretty good to go. Mm. And we've been in touch with a couple of companies that do this, and you know they've dedicated clusters of machines running overnight to make optimal logistics plans. And you know, if you want to do things like same-day delivery and that kind of stuff, it would be sweet to do it in one forward pass on a GPU instead.
So ultimately, this is also about doing something, solving a problem a lot faster and cheaper.
Yeah,
if you do it smartly.
There's two types of things that I think are compelling about AI. One is if you can do something that you're already doing a little bit more efficiently. And so that's nice. That's like a convenience. But the other thing is if you can do something so fast that you start thinking, can I build a service on this? Can I maybe offer a new product to somebody that wasn't possible before, like same-day delivery or package rerouting in real time. I don't know, something like that. That's what I think is a novel.
So basically, when you get to the next level of speed on this, you can actually start thinking about, well, how I put that into my service.
Yeah. Okay. So here's another music analogy. Imagine you're trying to write a symphony like Beethoven, and you have to write your score and then bring it to an orchestra, and then they play it, and then you hear it, and then you're like, yeah, that was no good. You have to go back and write it again. That's basically what people are doing nowadays. Which is why only Beethoven back then could do it, because it took a genius basically to hear everything in his head.
In his head.
So only like the best data scientists now can just sort of intuit these awesome things and then get it right on the first try. So it's not so much like, oh, now I don't have to wait for it. It changes everything when something is so fast that it's at your fingertips.
So basically, what is the core of the idea that you're working on right now, or that you want to explore with products and services?
The core of the idea is that a lot of companies have processes that stand to benefit from being optimized, whether it's how they pack their warehouse, how they send out their trucks, even a hospital, how they put people in line for the X-ray machine. You don't want to have it empty. You don't want to have a long line there. You want to have just the right person at the right time at the X-ray machine. So the bigger the scale, the more there is to benefit. But all of those kinds of situations, that's where we want to help out.
Yeah, so you've been really trying to narrow out on that particular type of problem.
Yes.
And how does that look like from a deep learning perspective? What type of problem is it from a deep learning perspective?
Right, so here comes a cool thing that I'm sure other people have thought about it, but I was sort of spellbound when I discovered it. I've always felt that graphs were very fun to work with. They're a fun data structure and there are neat algorithms for working with it. And it's also one of those problems, funny enough, that's very difficult to parallelize. All the algorithms for graphs are it's hard to split a graph in half and do the one half first. So we were working with graphs when we were in telecom. And we were like, okay, how can we apply AI here? And here's a fun intuition first. So convolutional networks are working on images, and images are just graphs where every node always has 8 neighbors, right? And then
six, or,
okay. Isn't it 6 and then 2 on the side?
Yeah, true.
Yeah.
8. Okay.
So,
thanks.
so, but it's a graph, and then I'm like, okay, well, we know convolutions work, and then, funny enough, after a couple of years, graph convolutional networks started being a thing, and they work precisely for the same reason that they work well on images, is because the locality thing applies just as well on graphs, and graph neural networks work really well. So we started playing around with those, and we wanted to try some simpler stuff first. And I discovered that word2vec worked really well on graphs.
What's this?
So there's this method called word2vec, an older language processing method that you feed it a sequence of words and it guesses what the next word is, basically. And I thought, well, that's sort of like a random walk on a graph. What if I feed it a set of nodes and I want to guess what the next logical step in the graph should be? And funny enough, word2vec was really good at that. It memorized the graph, and it figured out what the smart walks along that graph are. And obviously, it made an embedding in itself of the graph, the big graph into a tiny embedding in the network, and it became really good at walking across the graph. And now, do we know any other models that are really good at handling sequences? Right?
Oh, now we get there, yeah?
Yeah, so that's where transformers come into the picture. And funny enough, transformers are really good on graphs, walking along graphs, and so there's a more advanced version of the traveling salesman.
Because I think this is super interesting discussion, of course, and understanding and how to generalize sequences such as text into graphs is very interesting. But how do you really do that? How do you sequence basically a graph into something that you can then apply transformers or word2vec to?
I don't think you sequence the graph as such. What happens is, in the word2vec case, if you feed it a number of walks along the graph, it'll only make an embedding of the parts of the graph of the walks that you've fed it.
But basically, you find a path. That's the sequence, right?
Yeah,
so you basically sample paths through the graph, and that becomes sequences in some way, right?
And so you can't solve all kinds of problems, or maybe you can. I haven't thought about it enough, but for the convnet, you can make sort of an autoencoder style where you have one network that goes in. Let's say you want to solve the optimal network flow problem. And so you have a network, an energy network, let's say.
I was thinking.
Right? And one of the machines breaks down, and you want to know, how is the energy going to be rerouted? Is that going to make back pressure? Is it going to break some component? That's an NP-hard problem to compute. You could have a graph convnet that is like an autoencoder and spits out a more optimal network flow, or perhaps a predicted network flow, or something else like that. But that's not so much a sequence problem. A sequence problem, the kinds that we've been looking at are if in the case of telco, if a user is traveling along the highway, what is the most logical set of bounces along the towers? Because that's very stochastic. Like, you think you would connect to the best tower, but you don't. And so we wanted to make models that would guess what's the next tower that the person would probably connect to. And the fun thing is, what we've discovered is transformers can learn a lot more about the logic of the jumps between the sequences. So, for example, in the traveling salesman, the most optimal path that the traveling salesman would take is not necessarily a greedy approach, taking the shortest path and then the next shortest path. It might be something that looks less optimal, like you start with the node that's furthest away because the ones afterwards are shorter or something. And with transformers, you have attention. So the transformer will look at all the sequences it can take, and it'll say, I see that that's where I should be starting, and it can be really clever about things that are out of order and that kind of thing.
And for people that don't know the huge difference between word2vec kind of models and transformers, how would you describe transformers compared to word2vec?
I think, for me, the two things that are interesting are the attention mechanisms that transformers have. So basically, you can think of an attention mechanism as a softmax that puts the focus on what part of the problem that the machine should be focusing on next.
And this could be a sequence of words, or it could be a sequence of nodes in some path.
Yes. One thing that I haven't really wrapped my head around yet is I saw a paper quite recently that showed this working very effectively on images as well. That you cut up the image and it outperforms convnets. That boggles my mind a little bit. But Yeah, so the attention...
Sequence of pixels row by row, basically, right?
I think they tried using convolutions to bake down each quadrant in a picture into single vectors, but they found that they didn't even have to do that because the attention mechanism sort of figured that all out for it.
Exactly.
And so you have an attention mechanism, and what it does is, I think the nicest analogy is in language translation. I was fortunate when I was at Tele2. I was working on a what I thought was a pretty groundbreaking project, real-time translation of voice while you were on the call. We were going to connect it to the network, so you would dial, star blah blah, and it would translate you from Swedish to English or whatever in real time. And we were going to use Microsoft's API. And the fun part is when you're speaking in German, the translator has to wait until, has to place the verb at the end. So there's this huge delay when you're trying to speak German. And you'll notice that when you're in Skype or Teams and you turn on the auto subtitles, the German thing will wait and wait and wait, and boom, the verb comes at the end. Attention mechanisms let you sort of look at what's relevant in the sentence, and separate the order of things. So whereas old methods like recurrent neural networks would have to remember things for a really, really long time, a transformer can look at everything at once and just look at what's important in the moment instead of bringing along with it
everything.
This really long set of information. And that's probably why it works better, I think.
Yep.
And what was the difference to Word-to-Vec?
Word-to-Vec is Word-to-Vec even recurrent? I don't know.
No, it's not.
It's not.
Just
It's
a pair.
fully
Usually the
connected, right?
skipgram is just a pair of
Yeah.
nodes connected.
So
Predicting the next word you can think of, or a
Yeah.
context of a word. Yeah. So it's extremely much more simplistic. It's like a single neural network compared to like millions of parameters in the original transformers.
So this is interesting. So this is interesting now. I guess you have started to talk to people in industry around that, and do they fundamentally understand the difference? This is a leading question, but do you have any anecdotes for us on like how do people experience you or this understanding that there is a different route down to this problem? It should be huge in the transport industry, in the logistics industry to start thinking about it.
I mean, even small logistics companies are delivering tens of thousands of packages per day that they need to optimize. So they all stand to benefit. But the really big ones in this country here, they have a turnaround in the tens of billions of crowns. So any 1 or 2 small % improvement, we're talking about hundreds of millions. In potential savings. I think that's a pretty compelling AI argument if we're talking about business cases. And so, I'll speak about this topic, and it's not like people haven't thought about this before. And you're very safe buying off-the-shelf products. But when it comes to it, and you need to explain what the difference is, and that it's an ocean of difference, it's very hard to quantify it. I've had a lot of problems where I run the neural network, and it goes boom, and it's done, right? 300 milliseconds. And I'm like, did you catch that? Yeah, no? Yeah, it was pretty uneventful. I don't know what else to say, but how long does it take you guys to run? And it's, we run it on a cluster of 5 machines for all night. And it's like, yeah, so is this useful? And they're like, I don't know. I'm not sure exactly what happened. But we have this other use case, and then it sort of dies there. Yeah, I think what we've found, and this applies to everything else, you need to have pie charts and dashboards and dots and moving stuff for it to work.
As a sales pitch.
As a sales pitch. The first gigs we did at my old company, we did this really cool stuff with Cloudera, and we connected it to Power BI and connected it to Cortana. So you could say, hey, Cortana, how many units have I sold? And it would get it all the way back. So I was
Cortana is the voice assistant, basically.
Right, the voice assistant in Microsoft. And I was really proud of that whole thing. But the only thing that really stuck from that meeting was the voice activation. And it's the same thing here, where it's really tough to explain why, to big companies, why this is useful. To startups, it's different. So these little companies that live and die by the margins, they will take any small advantage they can. So that's where we've made more inroads than with the big traditional companies, where I think there's more to gain.
The real opportunities there, but is it as simple, fast, and happy? Or is it uneducated, or is it too hard? I mean, the big company always, to have respect, when you come with change, it's painful for them like hell to change or to adopt and put things in production.
I think at a startup, you can go speak to a CTO, and the CTO will be both the person that understands the full tech stack, has a 20% stake in the company, and answers to the board of directors, and has a time, and has everything in one place. And you can say, I can do it in this time, it's this valuable, and you can have one conversation with one person that understands everything. At a big company, you have the CEO that reports to the board and is only really interested in making sure that they get their money. What do you call it? The yearly
year-on-year growth kind of thing.
Yeah, that kind of thing. Not necessarily reducing operational costs in the moment. They want to get their dividends, stock dividends. Want to make sure that the dividends are good this year. Yeah. So maybe even the CEO that answers to the stockholders might not necessarily be interested in making operations better. So you end up having like 5 people that you have to talk to. The CTO that understands the tech, somebody that's responsible for operations, somebody that's responsible for the profitability of the company. So obviously that's a harder sell and conversation than the startups.
Before we move away from the paper that you submitted, and I think it's a fun topic that we really didn't dig deep into sufficiently. So perhaps one question is basically, what's the difference between taking the approach that the paper takes and trying to find an approximate solution to TSP compared to using machine learning or deep learning for that?
Yeah. The paper and the mathematicians want to find an exact solution to the traveling salesman problem.
Yeah.
And there is a provable bound to how much time it can take in the worst case.
And it doesn't even found in this case, I guess, the optimal one. It's
right.
just some kind of close to the optimal one that it can guarantee to find, right?
Yes. Deep learning models are not guaranteed to find anything special. We can sort of run it many times and say most of the times it looks like it finds a good solution. And that's the same with all these physics approximators and everything else. There are many heuristic methods already, algorithmic heuristic methods for finding pretty good solutions to the traveling salesman problem. Methods like ant colony optimization, genetic algorithms, simulated annealing, which is an inside joke because it sounds so advanced. Particle swarm optimization. All these methods are like gradient descent, I guess, that exists in machine learning. And they'll find a pretty good solution. The transformer, though, tends to beat those by quite a lot. It's both a lot faster and gets a better solution. But it doesn't find the optimal solution. Ever, basically.
Probably not. But still in the approach of what they take in the paper, trying to basically define an algorithm from a manual coding point of view almost, or mathematical point of view, compared to just throwing data to it and automating, I guess. Or would you say that that's basically the machine learning approach in trying to use data instead of manually coding it in some way? Or would that be a good way to describe it? Or how would you describe the difference of what the paper does and a transformer would do to try to solve the TSP problem?
All sort of complexity theory is in quantifying what each step of an algorithm does so that you can set a bound on what the worst runtime is. So it's really probabilistic, and you can set, you can give guarantees on how bad or good the solution from this is compared to the transformer method, which is very much reliant on the data that you give it. Coincidentally, I think the secret sauce that we have in how we've implemented the transformer is that...
so, by the way, you have like a prototype of using transformers for TSP?
Good. For sure. For vehicle routing. So TSP is just one person. And then there's the constrained vehicle routing problem, which is many trucks with many constraints, time windows for deliveries, how much packages you can fit in it. And we've made working prototypes that are very performant, very good. And what we're hoping to do this fall is sort of verify that it's useful. I think a lot of we've been speaking to companies that say, well, our biggest problem is that we only have 2 loading bays and there's always a queue. So, imagine we save each truck 15 minutes every hour. And then they come back to the loading bay and they're in line for 2 hours. So we haven't saved anything. So the point now is to verify that that this really does save time for real companies.
So just to understand, how did you actually build this transformer-based kind of route optimization problem? Did you collect data in the beginning somehow,
No.
or?
Well,
or
I'm not going to give away too much of the secret, but it's all. Okay, I can say all graphs are the same, really. So you don't need data from a specific graph.
Okay.
So the traveling salesman problem is generic enough that you can take data like road, how much traffic there is and other stuff, and that's useful. But the route finding intelligence is general purpose. So for that, you can use other learning approaches than training on data. So it's not a supervised approach that we've used.
Okay.
And
So it's a self-supervised somehow, that you basically predict the next step in the graph somehow? Or?
Yes.
Yeah. Okay.
Super cool.
You're gonna milk this one
Yes,
out?
I want to.
Yeah.
Coltum is always a self-supervised is the way to go.
We're gonna make it all open source, and it's all in Julia. So
I'll wait until I see that. But
Yeah.
okay.
But
No,
but
But before we close that discussion, I think
yes, please
a lot of people don't understand really the difference between using machine learning or deep learning compared to like trying to manually program something.
yeah.
And it would be fun. Okay, let me make a statement and see if you agree with it. So one, it's super hard to manually code and find like an optimal algorithm for doing whatever, including solving TSP or something else.
Yeah.
And then you can try to mathematically find some kind of bounds and do some guarantees on it. That can be useful, but usually it's kind of worst case analysis optimization that doesn't really speak about the real world and the average case
Right.
analysis and the
Yeah.
results. So in reality, perhaps you don't really need or have that much use for the worst case analysis that many of these papers focus on.
Sure.
Right?
Yeah.
And then the question becomes, okay, and given that if we were instead to care about like the average case analysis and the performance of that, then we need to find an algorithm that works really well for that. And then we can try to manually code it, or we can throw data at the problem and use some kind of model, like Word2Vec or transformers. And that basically, would you say it's basically like automating, building the solution to find the route somehow, or?
Yes. Well, so just with regards to the bounds of expert systems, if we call them that, that was something that bugged me a lot when when I was working on operating systems. You would be making a memory allocator, and you had a choice. Either you could optimize for the worst case scenario and remove the latencies, or you could optimize for the type of memory workloads that people tend to use. And you might get these tail latencies that were really long, but on average you would just be performing really well. And there is no solution one algorithm is good at one thing and another one is good at another thing. And it really bugged me that all the focus tends to be on the worst case.
Yeah. Especially in academia, right? Or
yes,
in
it's always something,
Yes.
but 99% of the time it's something else.
Yeah.
And I like that about deep learning and training on data or training on patterns, because it's pretty realistic, and I think we don't always know what contributes to the output as much as we think we know, and I trust the data.
Yeah. Can you share some kind of, if you have some initial benchmark results comparing like Word2Vec to transformer model in terms of performance?
I mean, Word2Vec was basically struggling to do Dijkstra's algorithm. So it could find the shortest path sometimes, but it would never be able to do this. I mean, we have a transformer that does the constrained vehicle routing problem in one forward pass and gets to within 2% of optimal.
Oh.
I mean, and it trains in like a day.
Oh, really?
On a big workstation.
And that's like a smaller version of a transformer? Or is
it's just a small transformer, but it trains. I mean, okay, so we have these nice machines from HP that have like 90 gigs of GPU RAM, but I mean, this is stuff that a company can buy.
It's not the GPT-3 10 million times.
No, not quite there yet. No.
I'm biting my tongue again.
So the joke is, isn't this a GPT-3 problem we can fix?
It could be. Maybe I need to outsource it to OpenAI or something. Yeah.
But to be frank and not make people think that this is actually true, then of course your fine-tuned version of a transformer would outperform GPT-3 if you try to throw it anything in a zero-shot learning setting.
Yeah.
By far.
Look, this thing is made only to solve this problem, and it's very tiny, and it's tiny because we know exactly what it's going to work with.
Yeah.
And yeah, it's not comparable.
But this conversation we also had a little bit like very, very interesting about how to be successful in understanding where to go with new products and toolings. And I think Luca said it, what's the opportunity for Europe? As one of our guests here, Luca from Peltoria, right?
Yeah.
And we talked about this, well, it's in the tooling. And then, okay, well, what type of tooling are we talking about then? And then we're joking about the GPT-3. But it comes down to, if we figure out, that we want to be world dominant, but in a quite concrete niche or a quite concrete algorithm, that seems to be not a bad idea. Because all of a sudden you can now come back to the whole idea that how do you do something with AI that is kind of cost efficient and simple and can even be where the complexity in the end, if it's one-dimensional problem, you can kind of hide that complexity in the end quite nicely. Think product, which if you do this too broad stuff, is just going to be... So I think this is cool. I think this is almost like a concrete example of what we're talking about, the technology. Yeah. We're using transformer approaches, but here we see now very concrete, very like this.
And you just need some web developers to make some nice UIs.
That's what I'm saying. That's.
I need to learn some JavaScript. I've been putting it off for all these
that out.
Do some React and then you're set to go.
Do some React.
That. Yeah. Yeah, cool. I'm trying to milk you for the details of this model, but I can see you shouldn't do that publicly.
No, but the thing that I think is really fun is the following. I think, I don't know if it's something about the Netherlands and the universities there, but all the clever uses of machine learning that use them in ways that others haven't used them come from there.
Oh, yeah.
I don't know what they're doing over there. But
which university? I know some people there.
I don't know, but I mean, I have some personal friends that come from there, and then all the papers that I think are cool come from there. So the Netherlands, I guess they're a good place, but...
Perhaps they are creative for other reasons.
They're creative for other reasons.
Right. Well, if we're going to go just touch on the Europe subject for a moment...
Maybe we should park... If we close this, we go here now. So I kind of think we've... Interesting stuff, but let's go to the next theme.
Well, this is a good segue because you were asking about, why this particular architecture and how does it work and stuff. And I'm a little bit proud of it because I don't know if it's unique or anything. I mean, a lot of.
Will you publish about it, or do you think, or will you keep?
No, we're going to put it all out there. I just we want to. I mean, it's pretty experimental for us. We're learning as we're building the ship as we're sailing it, and I think the thing is. I've made a couple of talks at conferences about talking about deep learning by way of analogy. If you're going to understand how optimizers work, it helps to think in terms of geometry and that kind of thing. And there are a lot of analogies that you can make to make sort of conceptual leaps that allow you to be creative and come up with new use cases. And
you mean basically optimizes in terms of understanding like the loss landscape and
for example, right? That was something
I know you have done some really beautiful visualizations there as well.
I've always imagined the spaceship going along the lost landscape and thinking, okay, well things are different in 4D, so a valley's going to be really deep in 4D and so on. But it helps to have that sort of analogy when you're going to make intuitions. So it's not immediately evident when people talk about transformers that they apply to sequences of anything like traversing a graph. And I just think that it's neat to encourage students to think of novel ways of implementing these tools. So I guess that's what they're doing in the Netherlands. And so I'm thinking now if we segue into what Europe should be doing to promote AI and to get ahead.
Yes,
I almost think it has to start at the universities more than in the companies.
Why is that, do you think?
So I feel like a lot of the people that come out of universities from the machine learning program have almost done like 1 or 2 courses in Keras or something like that. And that's the extent of the hacking. Whereas these PhD kids from the Netherlands are just doing these really bizarre experiments with architectures that maybe I can have the neural computing machine wasn't from there, but just why would you even come up with such a thing to begin with? Well, and skip connections and all that kind of stuff. Like, who comes up with that stuff? That's the kind of thing that I think people need to be thinking about to be able to come up with novel use cases for AI. Because right now, everybody's just looking at pictures and text, and that's the end of it. And you can use it for anything, obviously.
And I know you love Keras from the video that you
Right?
So what is Keras for everyone? What is Keras?
Keras is a tool that, under normal circumstances, it would take you 90 lines of code to write something clever, and Keras makes it so you only have to write it in 10 lines of code.
Yeah. And how does that fit in all the other coding languages? We maybe we keep that a little bit.
Yeah.
No, I mean, the only reason I mentioned Keras is because, to me, Keras is very much about getting stuff done.
Yes.
But at university, your job is not to get stuff done. It's to explore, the knowledge landscape.
But wouldn't you say that a mix, though? I mean, if you have great engineering skills and can actually build and test and, do proper experiments, that's a huge benefit as well, to be able to be creative in some way.
For sure. But that's why I use Julia instead of C. If I had to program in C all the time, I would never get anything done.
So let's explore the Europe place, because I really want to go into the language story here. We have another. You're the second Julia fan we have had on the show. But let's continue with Europe, because so the theory here is a little bit like, how do we get Europe back on track? And you are now pushing a little bit like, okay, let's really think about academia role in this.
Yes.
Whether we do other stuff, I think this is still valid, that we need to be much smarter of what we do in academia.
Yeah.
So what's the recipe? What's the Amsterdam way?
Oh, the Amsterdam way is going to be tough, but I think the Amsterdam way is probably to have machine learning specializations that let you work on the machine learning part for a much longer part of the time. So I feel like the machine learning specializations that exist today are basically computer science with 2 or 3 elective courses in machine learning. Whereas I feel like it's a very hands-on topic, like architecture or anything else, where you really need to spend quite a lot of time trying ideas and that kind of thing. And then I think that
you want more craftsmanship, hardcore machine learning craftsmanship as part of the curricula. Spending more time with learning different languages and doing the engineering stuff.
To be fair, I mean, the Netherlands papers that I see are very technical and mathematical. So they're not just hack and slashing. They know what they're doing. They rationalize all the choices that they make. And even if they don't, you know that they know what they're doing, because the intuition it would have required to make that logical leap and come up with that stuff, you need to know that that's a reasonable assumption to make.
Let's bring in one of the favorite topics, first principles, right?
Yes.
So you need to know the first principles to be able to reason and come up with the creative ideas.
Yes,
right?
Yes, exactly.
Yes, that is true. So you need to really master something. You really need to be able to give it apart and rebuild it in another way, or use it for another thing.
Yeah. And I think, here's a little rant from me, because it's fun. Tongue-in-cheek, guys. You have people that have studied statistics, and then they start coming and they need to implement it in distributed systems. And there are computer science facets of implementing algorithms in distributed methods that sort of throw a wrench into the stuff that you've learned at university. So if you're going to calculate the variance of a data set distributed, you need to take into consideration numeric stability and other things that you wouldn't have to take into consideration when you're just calculating it on one machine. And that's very much in the domain of computer science, and you might never come across it unless you've been forced to learn those algorithms either in courses or tried the algorithm yourself and found that you got negative values when you shouldn't be, and that kind of thing.
So what are we saying now? Like, so where should academia go to be even more relevant? And we are not talking about the PhD stuff now, or is this PhD stuff?
No.
Or is it basically the master degree, like just churning out students?
I feel like the master's degrees here have not gone deep enough. They need to commit completely to having like an AI specialization.
So you're skimming the surface on too many broad things. So they should be more. Okay, I really want to become a machine learning engineer.
Yes.
Let's go that way.
Yeah.
Okay.
And then there needs to be a tight connection with the industry. I really think that the startup scene and the connection with the industry and all that kind of thing is super important as well.
So just thinking about that and thinking about Europe versus US or China, and you can think about different investments we can make from EU Commission or from Swedish government or whatnot. And We can choose to spend a lot of money in improving academia, or we can choose to spend a lot of money in investing in companies that want to be more innovative or doing more AI research or whatnot.
Mm-hmm.
And then we can think about how it works in US, etc. Where do you think, if you were to recommend like EU commissioner to spend some money,
where to invest?
Where should they, where would they have the biggest gains, so to speak?
Man, it's very tough to be political like that. And the only reason I'm hesitant is because startups is not for everyone. Because it requires a bit of a tenacity that it's just not suited for everyone.
So I guess it 3 different ways. One could be like academia, make it more relevant, make use of later techniques, both in like AI and ever like data and computer science, whatnot. And also it could be like more enterprise type of companies that needs to be more innovative and use these techniques and more quickly, adapt to the current situation. And then it could be startups.
Yeah.
And having a better startup scene, which I think Sweden actually has a really good one compared to...
I think so too, yeah.
Right?
Sweden is really good about that, and surprisingly good about giving people opportunity without too many negative repercussions. It's very easy to start a company in Sweden. Like you can start a company really fast. Very hard to end a company, but that's another question. But I think if I were to pick between investing in big companies and investing in startups, it would definitely be startups.
Yeah.
Why is that?
Because they can take bigger gambles and make investments in the kind of innovation that is disruptive. It's not fair to expect a big company to. I mean, take some of the logging companies in Sweden that handle forests and that kind of thing. They have a very solid way of doing things that they've been doing for decades, centuries, maybe even some of them. And it's unreasonable to expect that they're going to change and digitalize everything.
Yeah, but it's a quite interesting question. Theoretically, EU Commission has 1 trillion or whatever, 100 billion.
Yeah.
How do we invest them? Use roughly. Is it 50% to academia, 25% to big and startup, or is it 100% just throw?
Very easy questions here for you to answer. And
yes, I know.
1% startup.
I'll give you the answer right now. Right?
1%
You ready
startup.
for it?
Yeah.
No, but I think one way that companies would like to work is it ties back to what we were talking about before, whether you should go into a cave and code for a year and then come back.
Yes.
I don't think that that's the right way to do it. You said you need to validate that something is good with a company. But if you do that, you tend to give away the value of your company, which is why people would prefer to go into a cave and then come out and then take that gamble. Wouldn't it be nice if you could keep your company but still have it verified somewhere else? So maybe the EU could sort of fund that cooperation so that a startup could develop something that's targeted at retail, but instead of IKEA or H&M buying that startup, they could just receive funding from the EU and get it developed together with ICA or H&M or IKEA or something like that.
So basically investments to have startups helping enterprises in some way?
Yes. So let's say that IKEA were to vouch for us and say, we're going to develop this together with Foxrane to optimize our warehouses.
Yep.
And under normal circumstances, either we would, if we were to do a joint venture, we would be giving away part of the company.
Yep.
And maybe we don't want to do that. And so we say, we're going to stay at home and code it ourselves. Maybe the EU could make it so that they could fund that work. So we could work for IKEA or H&M or whoever, but without having to worry about giving away all of the company in the meantime, if you're a fresh startup. Yeah. So a fresh startup out of university gets to keep the company, gets to get it verified already at stage 1, and gets to develop at the same time.
But actually, this is really
a good point.
I think this is fantastic, because if you think about that, how we have a welfare system in Sweden and how that is geared to a certain type of money. So we're giving money away in different ways, and we're spending a lot of money, which is more like for people out of jobs or startups. So the money is there. So it's a little bit like, how can we make it more simple to apply for this money? And it has a different flavor to it. It has this mentorship.
Yeah.
It has connection.
Yeah.
Maybe we are talking about a different style of arbetsförmedlingen.
Yeah.
So what's the arbetsförmedlingen
For startups?
For startups.
Yeah, that's a
And
that's not a bad
hardcore,
analogy.
what's the problem with this? It's just thinking first principle, what is this problem all about? And deconstructing it, seeing what the startup scene needs, and then create the startup.
It's a very funny way of putting it, arbetsförmedlingen for startups. Yeah.
Why not?
Yeah.
Yeah, let's move out of the EU discussions.
Yeah.
I've been forced to have a lot of discussions there recently, so it's not always the most fun thing to speak about. Something more fun to speak about is programming languages and how you become efficient in building systems where you can do data science in different ways. And I know you have some passion and affiliations
favorites.
A couple favorites, yeah.
We have a couple of favorites at the table. Which one is your favorite? You live in Python, we know that.
No, I mean,
you don't?
Yes, but it's not by choice, but it's by like necessity.
Basically.
For the company.
So I'm certainly not fond of the syntax and whatnot. But anyway, it's basically the go-to and certainly the number one language in the world today, even more than Java or whatnot.
Yeah.
And why do you think that is? If you were to speak about Python to start with, and why it's the data science go-to language right now?
Because it's easy for noobs to program with. Yeah.
Why is it simple? Just because all the libraries?
Because it's duck typed. It doesn't have. It just has a very simple syntax, all that kind of thing. You don't have to worry about very much.
And the main problems with Python is what you would say?
The main problems with Python, if we speak in very general terms, is that the syntax is so permissive that it doesn't allow the language to make any smart decisions for you. So it has to figure out everything right at the last second, which means it becomes very slow. Another thing is that the syntax is not is simple to learn, but doesn't necessarily lend itself well to expressing mathematical concepts. So if in some languages, you can write an equation almost the way it looks like on a math paper, whereas in Python, you're something dot obj dot function, and then you put it doesn't look very nice. So I'd say the two worst parts about Python are...
He's studying linguistics at university. So he also expressed it. For him, Python, I do not get it. It's like learning a new language. I cannot get Russian into my head. I can't get Python into my head.
Yeah.
And he said, Julia, I get it. So he thinks Julia now is a lot simpler. For him that made sense.
Yeah.
But maybe also because he's a mathematician, coming that way into it again. I don't know.
It could be. I think Julia is super easy to. The syntax is super easy. My background is mainly C and a bit of assembly. And that was from operating systems. And the thing with operating systems is it's very seldom you write large pieces of code on your own. There's a very big, well-established code base that's very optimized already, and you go in and you maybe change something, or you rewrite a function or something like that. It's very seldom that you come with a new memory allocator that's 10,000 lines of code or something like that. And
so C, you using libraries.
Yes.
Well.
And the thing I liked about C was that it mirrored how the machine works. Despite, I resented it when I came to university that everybody started off with Haskell. And the funny thing was that there were many kids from high school that knew how to program, including myself, and Haskell was so different that everybody was back at ground zero. So even the experts, they were like, oh my God, how do I express that as a Lambda function? I have no idea. How do you express Dijkstra's algorithm as a function? Who knows? But the teachers were like, this is the epitome of beauty. You think in parallel. Why shouldn't we program in parallel? And
theorists.
I couldn't. I don't know. I think I'm
waste of time.
I'm a bit contrarian, so that's why I was like, well, maybe it's not that way. And I refused to learn Java and all these other languages. And I remember at that time there was this one guy who was like, Python is good. It's duck type. If it looks like a floating point value, it is. And I'm like, is it float 32 or float 64 or a decimal or a big or a complex number? He's like, doesn't matter. It's good, bro. It works in Python. All right, sure. But then Julia came along for me, and it felt like it was still the machine, like C, but I didn't have to program that way if I didn't want to. So suddenly I could be 20 times more efficient without giving up that control that I felt like I had with C.
And for a lot of people that are at least somewhat knowledgeable about Python, how would you describe Julia to them?
So Julia has a number of pretty nice features. It has introspection. It has multiple dispatch. It's JITted. So you guys might be familiar with
just in time compiling,
just in time. Yeah, and you guys might know that from Numba or some PyPy or some stuff like that.
Java, perhaps.
Right? And the thing is, Java can be very fast if it's purely CPU bound and all that kind of stuff. But Julia is fast like that all the time. It's sort of awkward. You go to Wikipedia and you look up an algorithm and you program it basically the way the math formula works, and it's just fast out of the box. So I don't underestimate speed because, like I said, if it's 10% faster, it's one thing. But this can be like 30, 300 times faster. That makes a big difference.
What is it that speaks against Julia? Because it's sort of there, but it hasn't taken off. And is it growing, or is it more?
It's definitely growing in niches. So, like in gene sequencing, in economics, in very number-heavy fields is where you see it growing the fastest. And now data science is a number-heavy field.
So, if it's better, why isn't it growing faster? Or
it is,
like the Python nerds?
Python is like 20 years old, and Julia is a couple years old.
Yeah, when did it come out?
It's maybe more than a couple years. It's like 6 or 7 years old, I think. But
exactly.
Yeah. No, but it's growing. I think it's like Dvorak. It's gonna be big one day. Yeah.
And another angle on languages, or maybe not languages, but using GPUs for visualization.
Yeah.
I think you've been playing around a little bit with OmniSci and stuff like that.
I think you should take every advantage you can get, and for visualizations, sure. GPUs can be used for a lot of stuff. They're very hard to use on graphs, unfortunately. But there are a number of graph algorithms where you can solve them with matrices, and in those cases, it goes pretty fast, like if you want to solve it numerically. But I try to do as much as I can on GPUs just because the things you can run on them run so much faster. And you can really do anything. We were talking with this one company that wanted to say, well, if you can do packet switching faster, then we're interested. I'm like, you can do that on a GPU. You just get one of those Mellanox cards. The packets go straight into the GPU, and dictionary lookups on GPUs, super fast. You can do it. Yeah.
So let's go here, because like from languages now, you like Julia and all that. How does that fit in now with the whole GPU programming? Or is it different? Or can you run Julia? Or how?
Okay, so one of the cool things about Julia that separates it from Python is precisely that they've been really thinking about making the language introspective in such a way that it can make really smart decisions about everything. It's very composable. And this is going to tie into something that maybe you want to talk about in a sec about auto-differentiation. But you can write Julia code that's pretty abstract so that if it implements APIs that the communities has agreed on, like a matrix API, the underlying compute hardware is irrelevant. So
really?
You
can run it.
Yeah, so there are frameworks for machine learning, and one that I like is called Flux, and it uses just standard arrays, and you can run that at XLA on the Google TPUs. You can run it on GPUs. AMD's MROC stuff is
quite flexible.
Yeah, you can run it on pretty much anything.
That's pretty cool. And one last angle on this. Let's see if I can get it right. No, let's leave it.
So XLA and other techniques like LLVM and stuff that Julia has. How would you describe it? What does that do?
It's pretty sweet. OmniSci is a database that runs its filtering and aggregation, all that stuff on the GPU. So it's very fast. Either it works or it doesn't work, meaning if the data set fits in the GPU, it's just absurdly fast. And there's this really cool use case where you can have Julia code that you've written, and because OmniSci lives on the GPU and runs LLVM code, and Julia is JITted into LLVM, you can use a little macro called a little macro that converts your code into LLVM code, and then you can put it in as a user-defined function and run it on the GPU together with the database.
And what does that mean? What does that do?
That just
speed,
means that
is that speed?
Yeah, more speed, more faster. Everything working together a little bit seamlessly. The big downside here is that with Python, you get these ready-made things that are really nice, and you don't get that with Julia because AMD doesn't provide a TensorFlow version for Julia, and you don't get all that stuff for free. But if you're willing to invest a little bit in your own packages and that kind of thing, the composability is so powerful that you really, if somebody does an innovation in one package, you get all the benefits immediately. And the fact that most of the Julia ecosystem is written in Julia speaks for it quite well.
It's like Spark in some way, I guess, which uses Scala in some way.
Yeah.
That it's actually using that in itself. And actually, this is I think, interesting analogy that would be fun to see what you think about. So you are a big fan of doing parallelization in different ways, and how to work with threads or processes or whatnot, or free BSD could be another topic of discussion if we go there sometime. But I started with big data many years ago, like 10 years ago or something, and the process of turning an algorithm from having it run in sequence in some way in a single CPU to actually run on parallel in many machines is surprisingly hard. And you have to rethink the whole algorithmic design. And a lot of people didn't understand that big, necessity to actually translate algorithms into a parallelized version. And I would say, and I would like to hear if you agree, that the same thing applies with GPUs. So GPUs have these thousands of cores, and instead of a CPU having tens or something, and you have to basically have a way to convert an algorithm to run on GPUs in a fast way.
Yeah.
And actually, it's a very similar kind of problem. Would you agree?
It's the exact same problem, and it's very tricky. Yeah. So I have this one fun story. We bought an NVIDIA, what are they called? The Jetson TX2. Now it's old. Now they have the newer, cooler ones. But it has a GPU that's about half, or maybe less, but let's just say it's about half the speed of a 1080, something like that. And we wanted to run real-time video object detection using YOLO on it. And so I implemented...
So YOLO is a deep learning network for doing object detection,
yes,
basically.
one pass, multiple object detection on an image. And the TX2 is really nice because it takes the video frames and puts them straight into the GPU. And so as long as you're in the GPU, you're in good shape. And we had some other challenges like memory allocation and stuff that was a little bit tricky with garbage collection. But one of the challenges was that there were these parts in the YOLO algorithm that required... So there's this one function in Julia called find first. You give it an array, and it'll tell you where the first of a certain object is. So find the first number 5, for example. Implementing that on a GPU is not really easy. There's like a not elegant way of implementing that on the GPU. There are some references for how to do a scan like that, but there's no good way of parallelizing that. And so we were getting pretty good performance right up until that point. And so what we realized was we had to just take the rest of the stuff and run it on the CPU. And the first part was on the GPU. Right. And so some stuff, I don't know, we would probably have to rethink how YOLO works to get past that part. It's not easy.
But do you think it will come a point where Julia or other like Swift or TensorFlow or something, or Rust or Go, whatnot, kind of language will have sufficient intelligence, I guess, could be one term to call these kind of compilers that are becoming increasingly intelligent in some way, to actually automatically parallelize algorithms that doesn't require you as a human to do that?
So, no, I don't think so.
Okay.
I think they will get to a point where they will be able to tell if data structures are embarrassingly parallel and the operation you're trying to use on them. If like you're doing a typical operation, like I don't know, if you're doing a sort or whatever, and it knows that sort and this data set is parallelizable, it'll do it. It'll run it on threads or on the GPU. But there are some algorithms that just aren't parallelizable, that are sequential. For example, crack propagation in a rock. You can't calculate where the crack at one end is before you've started the crack.
It's a causality problem.
Right. And so some of that stuff you just can't get past.
So going on with the language part here. So moving away from languages, clearly when we talked with Carl to me and all that, we talked about putting data and AI in production. So what is your experience about the tooling landscape around what, let's say now Julia and all that. So how much are you living in the Kubernetes of things and all that?
Yeah. I think it's very unfortunate that it's gone so fast that it feels like a lot of people have just picked the first best thing they've found to get into production.
Deployment tools.
Yeah, exactly. Like Jupyter
tools.
Notebooks. Like Jupyter Notebooks are fun, cool things to program together with your friends at the office because you can both be looking at the same notebook. And even that doesn't work very well. But, it's a neat you're not supposed to deploy a notebook like it's code. You can't even version control notebooks in a good way.
Well, you made Databricks very sad.
Right? Yeah, people have been working around this. It's like, that's the Python way. You just add more stuff to it and more money.
So what's tell me a little bit about your reference architecture, how you think around Julia, and when you want to deploy it, how you
Let me just give you an example about containers.
Yeah, let's do it.
Okay, so have you heard of Singularity containers?
Nope.
It's the de facto standard for anybody that wants to run a multi-user system and containers. So if you go to any HPC installation, the Lawrence Livermore HPC, all these places, they run Singularity containers. What job scheduler would you use when running those containers? Oh, Kubernetes. Kubernetes is not a good job scheduler. You have Mesos, but real people, they run Slurm, SunGrid Engine, that kind of stuff. Like, we have these really tough tools that are battle proven, that are good. And instead, we're using these sort of web developer toys, Flask and that kind of stuff to put our stuff into production. And I think it's a missed opportunity.
Why is that? Is that because the AWS community grew up in web applications, and you need to get stuck with that enterprise tools?
No, but it works for them. It's not that it's bad tools.
No.
It's just that they've had version control and continuous integration, all these really good tools that work for web development. And then the data scientists, now they're like, okay, we have to actually have like structure to our development process. Let's do what they're doing, and they just take all the tools from that side. And
so, do you think there's better tools out there that is not really being used?
Yeah. Same thing with storage and all that kind of thing. Like, just because Hadoop is good at storage, we got to use Hadoop now.
I think you open a bit of a Pandora's box here, but okay.
Let's go.
But speaking about deployment tools, there are a number of them that are becoming de facto standards.
Yeah.
Like
Kubernetes.
Perhaps not only notebooks, but Kubernetes and these kind of other auto-scaling kind of tools. And then a lot of like scheduling tools and pipelining tools and whatnot. Yeah. But you mentioned some HPC tools, and I think this is an interesting discussion. And I've been recently also thinking or speaking about these kind of differences between HPC, traditional HPC.
What's this? What is
high performance computing?
High performance computing.
It's kind of big Cray computers or whatnot, doing whatever kind of weather simulations or biological kind of computation or whatnot. And then you have big data, which is the Hadoop or today's kind of Spark kind of tools or Dataflow or whatnot, or Flink and these kind of things. And then we have the whole like GPU kind of land, which is all different.
They're like three different ecosystems.
This is like three ecosystems: HPC, big data, GPUs,
machine learning,
and
sure.
Okay, keep going.
And then you can think, what is really the future in some way? Will they converge at some point? Are there clear differences in way of using them? So HPC will continue to move in some way with Slurm and whatnot? Or will basically everything converge even from big data into GPUs and this kind of... What's your thinking there? Will it converge or will it continue in the same kind of...
Well, what's very clear is the best product is not going to win. So you're right, because I used to think that FreeBSD was better than Linux in so many ways. Yeah. And if you add 1,000 engineers to Linux, then Linux is better. Yeah. Supports more hardware, does all the things you want.
Similar place for Python, I guess.
Similar for
Python. More people were using it.
Or TensorFlow.
Yeah, it's like, should I use Julia and rewrite everything? Or just use Python and use what everybody else uses and it works, and I know it works. Yeah. And it's the same thing for these HPC tools. It's like Slurm is 1,000,000 times better than the scheduler that's in Kubernetes, but maybe nobody cares. Maybe it's not useful. I mean, I think it's useful, and it's the same thing with Singularity, where I can use Singularity on my laptop and it doesn't mess up my file permissions, and it works like I would expect it to with SC Linux, and it works with MPI, it works with GPUs. but maybe that doesn't matter because Windows ships with Docker, and it's just nice, So I don't know, but I don't think that really matters for big companies because big companies have one sort of business, a core business that their revenue centers on, or maybe a couple of core businesses, and they can afford to specialize. So
this is an interesting idea. What are you saying here? You're saying that if you have a bigger business with a core thing, pick what is right for you and don't pick the standard. Is that what you're saying?
I think so, yeah.
So
and
basically, if Slurm is the shit for Vattenfall in energy, go there.
I think so, but then you have to also be of the mindset that you can't sort of sleep on these things for 5 years.
No.
I mean, if that's what you want, if you want to buy a data warehouse and then live with it for 30 years, okay, then you shouldn't be buying Cloudera or something like that. You can go with Oracle, but...
Okay, and sorry, another
delicious.
continued discussion here. I mean, I think it's a really interesting discussion. What will happen with HPC in the future?
Yeah.
I know the EU Commission is going to invest huge amount of money in that, and you can question if that's the right thing to invest in, but still, that's going to happen.
What's their bet that it's converging in that direction?
I don't want to say negative things here. I'm not sufficiently drunk yet, but sometimes having a nuanced understanding of what techniques that will win in the future, and it's not always the best technology that will win, as you said very nicely, I think, Robert. But anyway, thinking about cloud computing, which I know is one of your specialities as well, and this is also into deployment tools somehow. And let me start with a question, basically saying there are different ways to describe why cloud computing is useful. You can say, I don't want to manage my own hardware, I want to focus on the application or the service I'm providing. And you can basically outsource or let someone else, like a cloud provider, do that for you, and then you can continue that step or that kind of tech stack saying, I don't want to manage the operating system either, so let's have containers instead. And you can continue saying, I don't want to manage the whole scheduling of the application, let's just have cloud functions or something. What's your view of the future of cloud computing? Do you think that's the proper way to move as a company that wants to really have, like, let's say, the next Spotify in some way? Do you think cloud computing in that way is the right thing to
I
just
think so,
extract?
yeah. I think so because of the efficiencies that are in the cloud. There's no way you can run your own data center that efficiently. That's one thing. And then... the thing that I resent a little bit, I suppose, is these container solutions that I prefer are not the ones that are available as managed services in the cloud.
Which one is that, by the way?
Well, I mean, if I want to run Singularity, for example, I'm going to have to run Docker with Kubernetes, or I think Azure had Mesos for a while. I don't know if they still have it with their... Microsoft had a managed DCOS thing. Now that's gone as well. So you sort of have to pick what the cloud has, but I think sometime in the very near future, it's all going to go over to managed functions, and hopefully that's going to make things.
And
a lot
what do you
nicer.
mean with managed functions?
Well, it was funny when I started at Microsoft. Azure was brand new, and the only thing you could do on Azure was run .NET code. I just thought that was such a cool idea because Microsoft was different than Java. You had 5 languages and they all compiled to .NET, whereas Java had one language and it compiled to many platforms. But I was thinking then, like, okay, cool. No matter what language you program on, you can just throw it in the cloud and it'll run. I like that idea. But then they didn't have virtual machines, and Amazon had that, and so that everybody wanted virtual machines. But now it's becoming more obvious that nobody wants to actually manage machines and hard drives and all that kind of stuff. And we're going back to the sort of abstract compute fabric. I like that a lot because I don't care if they are less efficient than me. So one message queue software that I really want to give a shout out to is Red Panda. Red Panda is a C++ version of Kafka. It's much better. It's like Scylla is a C++ version of Cassandra. Much better. Anyway,
I love this.
I don't know how the message bus in Azure is, what they use in the background, but I don't care because I'm paying for ultimate uptime, and they can run it however they want.
Because really, we're here for business value, right?
Yes,
And ultimately,
yes.
we're here for then the real code, not to manage infrastructure.
Yeah.
The whole idea with cloud was to get out of that.
Yeah.
I get it. I think I follow your idea. Is this the way it's going? Is that the logical trend now? So it will be going back to the fabric.
I think that's the trend, and I think you really have to. I think when you're a startup, you can, for a short while, when nothing is important, when security is not important, when the ability to reshuffle your infrastructure is not important, and when 5 nines of uptime is not important, go buy a workstation and do it on your workstation.
But it's to get going, yeah?
Yeah. I mean, but pretty quickly, as soon as the other stuff is important, like, for example, you know, I want to expand my hard drives. Go buy one at Webhallen and plug it into your machine. You're going to do that? Or call one of your vendors and they're like, yeah, I'll be there in 5 weeks. Yeah, nobody has time for that.
Yeah, the cost of managing all the infrastructure and the hardware, etc., is something that I think everyone is underestimating.
For sure.
Completely.
Yeah.
TCO.
So the ultimate like goal in the end, would that be to have like managed Julia functions in the cloud?
Yeah, you know, we've been working really hard now because Microsoft has this thing called machine learning. They have machine learning, everything's machine learning studio and something else. But anyways, like a managed pipeline for machine learning stuff. And you can't run Julia stuff really easily because the way to get telemetry out and the way to invoke it is via Python. So we have to run Julia and then run PyCall to run the Python stuff.
Not elegant.
Yeah,
not elegant.
one day they'll get there when Julia is big.
Cool.
That'll happen right after FreeBSD is big.
Well, Mac OS is big, right? So FreeBSD is kind of, even though I know it's an Apple thing, so yes, it's let's skip that discussion.
Let's skip that discussion. I love it. This is a cool theme, actually, and there is more to explore here. But because I think it's also quite okay. So to wrap up this theme, so what does this mean in terms of strategy for enterprise? I mean, like if we boil it down now, so let's say Vattenfall or Scania or someone like that who is now trying and understanding their cloud journey. Yeah. How should they think? So if with the knowledge of these trends and with the knowledge of how it really works, you know, should they stay cloud native as far as possible? Should they embrace open source like hell? What do you think with your knowledge that you think is the pragmatic way to go? Also giving the fact that they are not rocket scientists or computer scientists,
right?
The whole bunch.
I think the trend of the cloud is undeniable. So that there's no question about that. It's not even. I'm not even sure why people would question that at this point.
Let me challenge that like question or that point, because I agree with you in the functionality and the speed that you can quickly get the service out there deployed properly is undeniable. But the big problem is that we don't have any Swedish or European kind of cloud providers today. And perhaps there are some other concerns, like ethical concerns or legal concerns, in being able to use American or Chinese cloud providers.
Oh, well, now we have. Then we can take a newsworthy comment into it, the whole shield discussion. Well, the whole. Are you into it?
I'm too busy trying to make the world a better place than to focus on politics.
Yeah, but all of a sudden, in the public sector, it's been a big controversy or whatever you want to call it.
Did you hear the philosophical kind of statement you just made? That's actually okay.
I missed it.
Okay. Anyway, sorry.
Well,
continue.
The thing is about these privacy concerns. I can't really speak from like a political perspective in terms of the reliability. I do know that all the cloud providers, especially Amazon and Microsoft, have gone really above and beyond to try to make sure that they can vouch for, how reliable and trustworthy their European cloud centers are.
I think this is all politics because it's naive to think that you can run something more reliable and more secure than they can.
I mean also from a sort of a trust perspective. They have these processes in place where you can go and check out the data centers and make sure that they are the way they promise that they are. Like there are these ISO processes that they've really gone above and beyond to make sure that they fulfill all the criteria for governments and that kind of thing. So
it's segmenting a bit into something that I would love that we had time for, which is you have an American background. we have US, we have Trump, we have NSA, we have whatnot. And but perhaps we should wait with that discussion
But you
until
wrap
later.
this up then, because I think the final part of the whole, we were going in deep on programming and then expanding on the all the environment around this, and the wrap up conclusion question was, how do I think as a normal company? What all that knowledge, what is your advice to a normal company coming into, go cloud and stuff like that? And you're wrapping that up.
I can only give technical advice. And what I would say is, if you're a hospital or something else where you have, or a military agency, there are cool techniques like homomorphic encryption and that kind of stuff that you could be using. So I feel like we can solve nearly any objection with technology.
Yep.
Yep. Awesome. I love like solving ethical dilemmas with technology.
Yeah.
I think instead of doing the opposite, which is regulating away technology, let's try to use
Solve it
technology
with
to
technology.
actually solve ethical and legal problems that we have.
Yeah.
I think that's an awesome kind of comment.
Maybe that's the wrap up comment then.
Yeah.
And let's take the next one.
Yeah, and we don't have that much time left, so I'd like to go a bit more into philosophical topics, and before we go into the art part, but thinking about AI and thinking about what perhaps Elon Musk and Stephen Hawking and other people are saying about AGI, the general type of intelligence that we may have at some point in the future. To start with, do you have a date
When it's going to happen?
It's going to happen.
I've been there and I came back. So if I were to say, it would sort of ruin the... But what I can say is it will happen. And for the opposite reason that I think a lot of people say. It's not that we will discover how to make generally intelligent AI. I think we are dumber than people think
Realize.
we are. Yeah.
Yes.
We're not quite as generally intelligent as people think we are. We're not very good at statistics. We're good at a very specific type of geometry. We're good at calculating parabolas when you throw things, where they land.
The physical laws in some ways.
Yeah,
you
just
can
throwing
understand.
rocks out in the savannah, basically.
Yeah.
And so we're very non-general purpose compute engines. But what we are very energy efficient. You can run on a hamburger for a long time. And you degrade very gracefully. There's this really
Degrading
nice...
what may?
I mean, when you're low on energy, you don't shut down. You just sort of become a little bit more dumb. And there was this really nice short story that I read recently about these aliens that were traveling the ether in the form of self-aware data on a substrate of a number of things. And they come to Earth and they find us like ants. And obviously they don't just kick the ant pile. They're like, okay, what are these guys doing? Let's check them out. And then one of the guys was like, oh, these guys are computers. And he's like, yeah, I can see they're moving. And he's like, no, they're made out of meat. The computers are made out of meat. And you have to keep it wet for the computer to keep running. And so what are they doing? Oh, they're just, they're throwing rocks. They're walking around, kissing each other and stuff. These meat computers. Okay, yeah. That's really all we are. And that's the reason why I think AGI is coming very soon, because pretending you're a human, and I guess this will bridge into philosophy. To me, pretending you're a human makes you human.
Oh, once again, pretending you're human makes you...
Yes.
human? What do you mean?
So let's say I just walked into this room here, and I'm not sure if you're cyborgs or humans. And I were to ask you, can you prove to me now that you're a human? And you'd be like, yes, a flower blooms only in the spring. And you'd recite some poetry or something like that. I'm like, easy, GPT-3, right? And ultimately, who am I to question what you are? I think that I could make it. It's not something that really appeals to me, but I could say, okay, if you're handicapped, are you less human? I don't think that your humanness has to do with a list of check boxes that your meat computer fulfills. And so I feel like a computer could very easily fulfill any number of criteria that make them very lifelike and intelligent and compelling. And yeah.
I mean, I like what you said, that humans are not very general, actually. It's very in a line with what, for example, Jan LeCun thinks.
Yeah.
And he hates the term general intelligence, and that's something that humans have. Of course it's not. He says human level intelligence is probably a better term to use for what humans have, and it's certainly not something to strive for potentially in AI.
Yeah.
Right?
Oh, I agree. I think we're people are very preoccupied with trying to make a machine that's exactly like a human. Why would we want to do that? I think it's a fun thing for sure, but obviously humans are very specialized, and so it's very difficult to make a human that's exactly, or a machine that's exactly like a human.
Yeah. So just pushing you. Oh, sorry. Last comment. I would sort of push him on the date as well, because you can either think like Ray Kurzweil, and I think he says he's very much into this kind of exponential thinking. And says 2029 is the date for general intelligence, and then you can take the other extreme. I think Mikio Kaku says something 100 years ahead before we actually have some kind of general intelligence similar to humans. What's your thinking in that type of range?
So there are some computer scientists that I like a lot that have sort of philosophized about how intelligence comes up as an emergent property. And it really appeals to me that the human brain would be multiple machine learning models sort of competing and collaborating and that kind of thing. And so I don't think we need to come up with one model that is the intelligent model, but rather, the visual model, the ear model, and all that kind of stuff. And I think it's going to take a really long time to make an artificial human.
From a robotics point of view, or from a intelligence point of view?
From a compellingness point of view, one that can, if we just imagine that we had the perfect android and all we had to do is put in a brain, or you could even have a cable so the brain didn't have to fit. Gluing all those little components together, I think, would be harder than making the component. I almost think we have the components today, in a sense.
Like each separate component.
Yes. And the thing about language is a bit of a silly one, because why we're trying to solve language and why it's so difficult, and that's because it's isomorphic to reality. So if we're talking about the what's his name, Chomsky, and the language structure thing, language has a structure because the thing it describes has a structure. It's isomorphic to reality. And if we assume reality has a structure and has one thing affects another thing, now maybe there are universes where it's not like that, and in those universes languages aren't like that. But I think we almost have the models today to make general intelligence, and what's missing is gluing them together in such a way that they mimic a human perfectly. And I just feel like that's an exercise for people that are really passionate about that specific problem. But if I were to guess a date.
Yes, I've been pushing for a long time now. You can cop up.
I heard, I saw a meme the other day. We're closer to 2050 than we are to 1990. So 2050 can't be that far away. So maybe I should push it forward a little bit. I'm going to say 2070, middle of the road.
Really?
Yeah.
Oh, surprising.
Yeah, because you think it's going to happen fast, but still, fast is still relative.
Yeah, I think we have solved the bits. I think it's the glue that's difficult right now.
So what are the major differences, you would say, between a human brain and deep learning or AI as it works today?
I don't think there's a huge difference. I think human brains are very energy efficient. But if we ignore that part, I think this falls back to what we were talking about before, that humans aren't as noteworthy as we make them out to be. They're very easy to fool.
Yeah.
A lot of people make fun of that the convolutional networks can be tricked by one pixel. Brains can be very easily tricked into having epileptic seizures if you blink at them the right way. Brains are not... We can trick brains into doing really dumb things as well. So I don't know... The thing that I thought was fun about convolutional networks was that obviously evolution, by way of its optimization function, death, has made a very energy efficient set of connections in the eyes for processing precisely that structure. And maybe there are energy efficient ways of doing that in computers, but the general principle of taking linear things and turning them into nonlinear, it's not really more complex than that.
So if we take a more concrete example, I think what you're saying is basically that humans, for one, should not be like over romanticized in some way. We're not that intelligent that we make ourselves to be or sound like sometimes. And let's take a concrete example. Let's say that we have self-driving cars. Let's say that we want to make a decision I want to basically go from point A to B in the most in the best way possible. What do you say? How should we make the decision? Should we have the machine driving the car or the human? Is it simply a matter of statistics saying, self-driving cars get into accidents this often, or is it something else necessary to handle more like ethical dilemmas that may occur or something?
I think humans are very bad at ethics. It's like we're pretending like we've solved the trolley problem, which we haven't.
Yes. Yeah.
And I don't know if that's like a machine learning issue very much. We're only nervous now because all of a sudden there's more machines that are doing these kinds of things, and we still haven't figured it out. Yeah. It's like the question of what is a human life worth? We're making those decisions now with Corona and all that kind of thing.
Yeah, true.
Should machines be making those decisions? I don't think it really is related to AI. I think we should keep developing self-driving cars and all that kind of thing. And sooner or later, we're going to get to a point where AI is unequivocally better than humans at driving cars, and then it won't be an issue anymore.
So basically, by just follow evolution, at some point it's just statistically safer. Don't worry about it. Just do it.
I think so. I heard one guy that said if we're going to resent or reject our robot overlords, and he said that we would, I'm not sure, but I like the idea. He said that we would see them as our children and we would love them. Yeah. Maybe. That doesn't sound weird to me.
Sounds good. Cool. And it's almost like, I think, being able to build an AI system in some ways is not only in terms of engineering, it's also in some way about creativity and I think art as well. For sure. Would you agree?
Yeah.
And knowing that you are, almost annoyingly good in both these terms, in terms of like digital art and music, how come your passion to start with for example digital art, and you have you have a website, right, that you can
I've put up my music and my videos and that kind of thing, and I'm trying to work on something now. I think it's a lot of martial artists say this, that martial arts is the expression of their true self. Sort of, they don't have to say anything. They move. I guess dancers feel the same way. I think art is a way to expose your feelings without any pretense. It's a way of expressing your capabilities, your craft, and all that without a facade of rationalism on top. It's just you through the thing you're doing.
So that's actually connected to one of my definitions of art, which is basically work that you don't have any use for. And I guess you don't like it, but in some way it's not a pretense of you have to build something to use it for that. You actually do it for other reasons, and then you figure out, what the use potentially is at a later point in time somehow, right?
Well, I mean, you can make something that's useful that's also a work of art, but I think when you are smithing a sword, the craftsmanship and all of your years of experience are the only thing that show in it, and that is the artisanship and the art in the thing. And it doesn't have to be your craftsmanship and your skills don't have to be put into something useful. You can put it into music that no one will ever hear, and it'll still be a piece of art, I suppose. And then somebody might be able to appreciate it. I do think, here's a question that I'm not sure about. Can you make a piece of art and then throw it away and nobody ever sees it? I'm not sure about that one. I think somebody has to see it, even if it's just yourself.
What do you mean? Is it not art? If I draw an art in the sand, and the waves wash it away, is it not art?
I don't think so. Because I think art is about community. It could be community with just yourself. I think of philosophy very much in the same way.
So, but we all play guitar at home, or we play, or we paint at home. I guess we don't call ourselves artists, but isn't it art for your own good?
For sure. I mean, you can make a painting, hang it up, and then look at it, and then I guess you are both the creator and the audience. But I think it needs to both be produced and consumed.
Because somehow. You have the community, the definition of art you had before. If you reiterate it, it's something we come together and define together as a community, as art.
And you can be a very small community. that consume your own art. And I think philosophy is very much the same way, because some, you can sit and meditate. And
do you meditate, by the way?
I don't know if I'd call it meditating, but
I do, by the way.
I think to myself. Yes. I guess maybe that's meditating. Yeah. And so if you just give monologues, that's not philosophy, and that's not meditating, right?
But okay, speaking about art being something defined by the community, would you welcome an AI into that community?
Yeah. Yes, I think so. I think people would say it's not art if an AI makes it, or what if does an AI take away something if it's able to make music? I think AI can make better music than humans, and music that I would listen to. It wouldn't rob me of my enjoyment of writing guitar pieces or listening to guitar pieces. I don't really feel like it takes away anything.
What's your art all about? Could you explain a little bit about what you are doing as an artist, what you've been focused on as a digital artist?
I have a little bit of a magnum opus that I've been working on for way too long now. And
please elaborate.
As soon as I have a little bit of more time over, I'll be finishing it. But I have a book and a piece of music that I've been working on for many years. And the book is about philosophy, nihilism, and it has lyrics for the songs that are written in open and in verse, usually iambic pentameter, sort of like Shakespeare. And then the music is a little bit of everything, but I guess my favorite part is the prog metal and the jazz stuff.
So this is an opus that's been going on for a while now.
Yeah.
How long have you been working on it?
Probably 10 years.
So 10 years. And what was the original idea? What's the idea behind, what got you going, and what's the idea here? When are you finished? I mean, like, that's ultimately.
I want to be finished like in a year.
So what's the definition of? So what's the goal? What's the definition of finished?
There's this thing in philosophy called the hermeneutic spiral, where you can only understand poetry if you already know a whole bunch about it. If you know it, and it came from the Bible. You can only understand the Bible if you understand Jewish culture. But Jewish culture is defined in terms of the Pentateuch and that kind of stuff. It's the same thing with poetry. You can only understand poetry if you really know everything about Shakespeare and these guys. But you can only really appreciate Shakespeare. So it's a bit of a circular definition. And I feel like it's a bit more of a spiral, because every time you come back to the other side, you're not really where you started. You're a little bit higher up or something in your plane of understanding. And so I in the book, I want to do this little journey from, if you ask yourself questions like, what is mathematics? It starts with philosophy, then it goes to math, then physics, then biology and people, and then goes back to philosophy. So that you have like a nice little circle there.
So what's the next steps in the life of art for Robert?
Yeah, I'm moving into a new house. I'm going to have a nice studio. I'm hoping to record all the music there.
Is a new album coming up or some new video coming up soon? Or?
Yeah, I'm thinking of making a music video with the company.
Oh, nice.
And I think there's a new trend now. Instead of releasing albums through record companies, you release singles and you put them up on Spotify. So I guess that's what's going to happen. I've been holding off on this 2-hour record forever. I think it's better to just release a little bit of snippets here and there.
So moving house, I guess you are building a house. How's that journey to build a house?
Yeah, it's my curse to bear, learning all these new things. Many people just buy a house or build a house, but I needed to know everything about all of that. So that's also
you took your passion and your nerdiness, if I may say.
Yeah, did you know you can program houses? There are these, I didn't even know that. Normally when you turn a light switch on and off, you break a circuit. But in cool houses, a switch is connected to a bus, and it's connected to a computer. Yeah, it's a rabbit hole.
Home automation, it's the way to go.
Yes.
So you AI-ified.
Yes.
House.
And what's next in the professional life of Robert then?
Yes, my dream is to put a novel AI to good use. And I really love this complexity theory, and we have some really nice use cases for it in logistics. I think there are some other smaller scale use cases for it in healthcare and other places, but we'll sort of see where it lands most naturally.
I think you should publish something about that. I haven't heard, I probably missed it, but I haven't seen that much of Transformer used for graph networks. So
okay,
that could be...
I don't know, how do you put it on archive? I don't even know how that stuff works. I never got my degree.
It's another discussion at some point, perhaps.
Back to archive, is that a good...
Yeah. Cool. Should we end with the final question? Basically being, who would you like to see on this podcast?
Oh, who I would like to see. I think, I don't know if I should be shouting out names, but...
yes, please.
Yeah, I would put them on the spot right now, and they have to come here. Let's just put it this way. There are a couple of smaller logistics companies that operate mostly in Stockholm, but even in some of the other cities, and their CTOs are all really clever people. They all studied at KTH or Chalmers. They're good in algorithms, and they're connected very much to the profitability of the company. And I think
it's not retail companies, really logistic companies you're thinking about?
Yeah, delivering and packages and all that kind of stuff. And I think I like the numbers of it. I like being able to count because it costs to deliver a package. And so being able to say, how much this tech investment actually pays off. I think that's a cool position to be in.
I have to ask, just because Amazon is coming probably soon to Sweden as well, and they have their own logistics and extreme use of data and AI.
Yeah.
What do you think will happen to Swedish logistics and retail companies?
I happen to be privy to some inside info with regards to that, and it doesn't look super good. Because part of their value proposition in the US and other places is same-day delivery and that kind of stuff. And that's really tough to do. Not a lot of companies can do same-day delivery and that kind of thing.
Or same-hour delivery.
Right, yeah. I think Sweden's in for a challenge with Amazon coming in.
Yeah. Well, I think you have given a lot of really awesome advice here for how we can in Sweden really and Europe start to accelerate.
Right,
and,
Robert 2020? No. That's it.
Well, as I expected and as we were hoping, it's been a true pleasure to have you here, and wish we had more time to speak more about the passion and the philosophy and all these kind of things as well.
Cool. It was super nice being here.
Yeah, super cool, Robert.
Thanks.
Thank you a lot.